There was this famous and honestly slightly cruel joke that used to go around university philosophy departments back in the mid-20th century.
Yeah, I know exactly the one you're talking about.
Right. It went something like this. If you went to a lecture by the brilliant philosopher Hilary Putnam and you, completely disagreed with his core argument, you didn't actually need to stand up and argue back.
Yeah, it's such a brutal piece of academic lore. But the punchline is that you literally just had to be patient. You wait about 18 months, and Putnam himself would publish the definitive refutation of his own idea.
Exactly.
And, he would dismantle his own theory way better than you ever could have, complete with exhaustive footnotes.
I love that story so much because it points to something incredibly rare, especially today. I mean, in a world where everyone defends their positions to the bitter end, Putnam treated his own theories the way a structural engineer treats a newly designed bridge.
Right, he didn't just build it and admire it.
No, he actively drove heavier and heavier conceptual trucks over it just to see where the load limits were.
Which is such a fascinating mindset, and it perfectly brings us to the mission for today's deep dive. We are exploring a really incredible book called Reason and Reality, The Restless Mind of Hilary Putnam, and it's by the author Boris Kriger.
Yeah, and we really need to make it clear to you listening that this is not like some dusty chronological biography.
Not at all.
What is completely new and original in this work is that Boris Kriger treats Putnam exactly the way Putnam would have wanted to be treated. I mean, he argues back.
And he brings some serious modern firepower to that argument, too.
Oh, absolutely.
Boris Kriger uses cutting-edge work in the science of complex systems, mathematics, and algorithmic theory to just collide directly with Putnam's most famous conclusions.
It results in this incredible intellectual friction. We basically get to see 20th century philosophy stress-tested by 21st century data science.
Which is wild.
So, if you've ever wondered about the true nature of your own mind, or if you've been grappling with the sudden explosion of artificial intelligence and what it actually means to think, this deep dive is going to give you a masterclass.
Yeah, and even beyond the AI of it all, this is really an exploration of the ultimate intellectual superpower, the willingness to lose an argument with yourself.
Right. So, to understand how Putnam constantly changed his mind, I think we first have to look at the theory of mind he invented. A theory that, quite frankly, still completely dominates cognitive science and tech culture today.
Yeah, so to set the stage for that invention, we really need to go back to the mid-20th century. At the time, the dominant idea in neuroscience and philosophy was something called type identity theory.
Okay, let's unpack that. What does that mean?
Well, it was this very rigid idea that a mental state, let's just use the feeling of pain as an example, is identical to a specific physical brain state. So under this theory, pain literally is just the firing of a specific neural pathway in a mammalian brain.
Meaning, if you don't have that exact specific mammalian brain tissue, you just can't experience that specific mental state.
That was the implication, yeah. But Putnam just flat out rejected this, and he used a pretty brilliant biological counterexample to do it, the octopus.
Oh, I love this part.
Right, because an octopus evolved along a completely different evolutionary branch than mammals. I mean, most of its nervous system isn't even centralized in its head.
Right, those neurons are distributed throughout its 8 arms.
Exactly. Its physical wetware looks nothing like ours. Yet, if an octopus injures a limb, it will guard that limb. It will change its movement patterns to protect it. Given the choice, it will actively seek out anesthetics.
Which is crazy to think about.
By any behavioral metric, it is clearly experiencing pain.
Okay, so wait. If an octopus is in pain, but it doesn't possess mammalian brain tissue, then having a mind can't just be about the physical material.
Right.
It's not about the specific meat, and by extension, it wouldn't be about the specific silicon in a computer either. It has to be about the functional organization of the system.
Exactly. And Boris Kriger highlights a fantastic analogy from the text to make this really concrete, the mousetrap.
The mousetrap, yes.
Think about what makes a mousetrap a mousetrap. You can have a classic wooden board with a metal spring. You can have like a plastic box with adhesive inside. Or, if you live on a farm, you can just have a really reliable cat.
A cat is a great mousetrap.
But they share absolutely zero physical materials. They don't look alike, they aren't built alike, but they all fall under the category of mousetrap purely because of what they do. Their function defines their identity.
This realization by Putnam was basically the birth of the computational theory of mind. The idea that the mind is just what matter does when it's organized in a certain highly specific way.
Yeah, and it essentially freed psychology from the constraints of neurobiology. You could finally study the software of the mind without needing a perfect map of the brain's hardware.
It was a massive breakthrough. But, true to form, Putnam eventually started doubting his own brilliant theory.
Of course he did.
He spotted a fatal flaw. If the mind is purely just a functional pattern, just a system of inputs mapping to outputs, you run into a really bizarre mathematical problem.
Yeah, the bucket of water problem.
Right. A sufficiently complex, randomly sloshing bucket of water contains millions of interacting molecules. Statistically, you could theoretically map the random movements of those water molecules to represent the functional states of a human mind.
Just because of the sheer complexity of it.
Wait, really? Just by arbitrarily assigning meaning to the ripples?
Yes. Through sheer mathematical coincidence and extremely complex mapping, an outside observer could claim that the bucket of water is functionally mirroring human thought.
That is nuts.
It is. And Putnam realized that if functionalism means a bucket of water can be a mind just by looking at it through a complicated mathematical lens, then the theory is broken.
Because it means panpsychism wins by default.
Exactly. The idea that literally everything is conscious.
So, what's fascinating here is how Boris Kriger steps in to solve this exact problem. And this is a completely original contribution in the book. He introduces a concept called identity as algorithmic configuration.
Which sounds super technical, but it's brilliant.
Right. And to get away from the heavy jargon, he's basically bringing in the science of data compression.
Yeah, and this is where Boris Kriger's background in complex systems really shines. He argues that identity isn't just an arbitrary mapping applied by an outside observer. True identity is compressible.
Like a zip file.
Exactly like how a zip file works on your computer. You can only compress a file to a smaller size if there's an underlying pattern or regularity to the data.
Right, because if a file is just pure, unadulterated random noise, a compression algorithm literally can't shrink it. The compressed version would be just as long as the original file.
Because there's no rule to summarize the noise, it's just pure chaos.
That makes so much sense.
So, applying this to the mind, Boris Kriger argues that a human being is defined by our regularities. We have habits, we have predictive thresholds, we have patterns of behavior that our friends and family can anticipate. We are highly compressible algorithmic configurations.
While that sloshing bucket of water is completely incompressible.
Yes, a random bucket of water cannot be compactly mapped to represent a human mind without a description that is longer and more complex than the bucket of water itself.
Wow. So Boris Kriger's original framing rescues Putnam's functionalism.
It completely saves it.
It proves mathematically that true identity requires measurable data compression within the system itself. You can't just project a mind onto a puddle. The system must contain its own highly compressed regularities.
It is such a satisfying solution, but it immediately sets up the next domino to fall.
Right.
If the mind is a functional machine, a compressible algorithmic configuration, can it exist in a vacuum? Does the internal software of the mind mean anything on its own, or does it absolutely require the outside physical world to anchor it? Okay. To answer that, Putnam constructed one of the most famous and debated thought experiments in 20th century philosophy. It's perfectly designed to test where meaning actually lives.
Oh, the twin Earths scenario. I love this one.
I'll let you take the wheel on this one because it's a bit of a mind bender.
It is, yeah. It requires a little bit of imagination. So picture the year 1750, long before human beings had any concept of molecular chemistry.
Right, nobody knows what a molecule is yet.
Exactly. Now imagine that somewhere out in the galaxy, there is a planet called Twin Earth. It is a perfect atom-for-atom replica of our Earth, right down to the people. You have an exact duplicate living there, living your exact life, having your exact thoughts.
So internally, our brains are in identical states.
Perfectly identical. But
Right.
there is one invisible difference on this planet.
Yeah.
On Twin Earth, the clear, refreshing liquid filling the oceans, the rivers, and the teacups is not H2O.
Oh, this is the Yeah, it is a completely different, highly complex chemical compound. We'll just call it XYZ. Macroscopically, it behaves exactly like water. It looks like it tastes like it boils at the same temperature.
But at a molecular level, it's totally alien.
Yes. So in the year 1750, you stand on a beach on Earth, point at the ocean, and say the word water. Millions of light years away, your exact twin stands on an identical beach, points at the ocean of XYZ, and says the word water.
And because we are perfect duplicates, our internal cognitive states are exactly the same.
Exactly. But here is Putnam's trap. Are you two meaning the same thing?
Well, we can't be. I mean, I'm referring to a reality made of hydrogen and oxygen, and my twin is referring to a reality made of this XYZ stuff. We're talking about two fundamentally different physical substances in the universe.
Which led Putnam to his most quoted conclusion, meanings ain't in the head.
Meanings ain't in the head.
Right. If two people can be internally identical yet mean totally different things by their words because of the environment they are standing in, then meaning isn't just an internal psychological concept. It is an external relation.
It's connected to the world.
Exactly. The word refers to the physical stuff it was historically and causally attached to in the real world, regardless of whether the speaker understands the deep chemistry of it.
And this is where we really have to connect Putnam's 1970s philosophy to the absolute explosion of artificial intelligence we are seeing today.
Oh, absolutely.
Because large language models are basically the ultimate test case for meanings ain't in the head. We are training AI on billions of words about water. The machine has processed every poem about the rain, every nautical map of the ocean, every chemistry textbook breaking down H2O.
The AI itself is just code on a server.
Right. It has never touched water. It has no physical causal connection to the ocean. So when the AI generates a sentence about water, does it actually mean water?
That is the defining question of modern cognitive science. And this is where Boris Kriger provides a highly original and honestly rather sobering mathematical answer.
I am all ears.
So, to explain what AI is actually doing, Boris Kriger draws on his own statistical research into undeciphered ancient scripts, specifically the graffiti found in the ruins of the Indus Valley civilization.
Wait, that's quite a leap. How does a dead language that nobody can read tell us anything about ChatGPT?
It has to do with how structure survives even when meaning is completely lost. Boris Kriger proved mathematically that sign convergence, which is essentially the complex statistical structure and grammar of a language, remains perfectly intact even when all reference to the real world evaporates.
Okay, give me an example of that.
Think about cryptographers looking at the Indus Valley symbols. Just by tracking the statistical frequencies, they can figure out that a certain symbol is probably a noun because it always clusters near another symbol that acts like an adjective.
Ah, so they can see the blueprint of the language.
They can map the entire blueprint. They can see the statistical regularities of how the signs interact, but they still have absolutely no idea what the signs refer to in the physical world.
Right.
The causal link to the ancient humans who actually pointed at real-world objects and named them has been completely severed by time.
Which means structure and meaning are two entirely separate things. You can have perfect structure with zero meaning.
Exactly. And Boris Kriger argues that modern AI is structurally identical to that undeciphered Indus script. The AI has perfectly mapped the statistical relationships between our words.
It knows that the word ocean clusters statistically with the word blue and wet.
Yes. But it completely lacks the causal chain to the physical world. It possesses the structure of our language, but the reference, the actual aboutness that connects the word to the physical universe isn't in the machine, just like it isn't in those ancient clay tablets.
That is a staggering way to look at it.
Yeah.
The AI is just flawlessly simulating the grammar of a dead language it doesn't actually understand.
Pretty much.
So, following Putnam and Boris Kriger, our thoughts and our words absolutely require a physical, causal connection to the external world to carry any real meaning.
Correct.
But here's the catch, that logic opens up a rather terrifying trapdoor. What if the external physical world isn't there at all?
Ah, the ultimate skeptical nightmare.
Right. The brain in a vat scenario. I mean, pop culture is obsessed with this, the Matrix being the most obvious example.
Classic.
The thought experiment goes like this. Imagine an evil scientist sneaks in while you're sleeping, removes your brain, drops it into a vat of nutrient fluid, and hooks your nerve endings up to a supercomputer.
Naturally.
The computer starts feeding you a perfect simulation of your life. You think you're sitting here listening to a deep dive, but in reality, you are just a wet piece of biological tissue floating in a jar on a lab bench.
And for centuries, philosophers argued there was no way to definitively prove you weren't in that vat. Because any evidence you gathered to prove you were in the real world could just be part of the simulation fed to you by the computer.
Your senses are entirely compromised.
Exactly.
But Putnam wasn't satisfied with that. He actually constructed a mind-bending linguistic proof to show why you cannot possibly be a lifelong brain in a vat, and it builds directly on that twin Earth logic meaning we just talked about.
Okay, let's trace his logic here.
If you had spent your entire existence as a brain in a vat, you would have never once interacted with a real physical tree, a real physical person or a real physical vat. Your entire vocabulary only has a causal connection to the computer code generating the simulation.
Which means your words only refer to the code.
Exactly. Wait. I mean, that is the crucial mechanism.
Yeah.
Your word vat doesn't mean a physical vat. It means the digital pixels representing a vat in the simulation.
Right.
Therefore, if a brain in a vat formulates the sentence, I am a brain in a vat, it is essentially stating I am a digital code brain in a digital code vat.
But that is factually false.
It's false. It's a real biological brain in a real physical vat. The sentence literally self-destructs based on its own rules of reference.
It's such a beautifully elegant trick of logic. Putnam used this linguistic self-destruction to argue that we must be causally connected to a real physical world. Otherwise, our ability to even formulate the skeptical question just falls apart.
It's brilliant.
It is. And to fully escape the vat, Putnam eventually adopted a stance called direct realism. This is the philosophical claim that our minds are in direct, unmediated contact with the external reality. There are no internal representations, no sensory filters getting in the way. We simply perceive the world exactly as it is.
And here's where it gets really interesting, because I have to push back on Putnam's conclusion here.
Yeah, it's a bit of a stretch.
The linguistic proof is clever, but direct realism just seems biologically impossible. I mean, we are bounded organisms. It takes physical time for light to bounce off an object and hit our retinas.
It does.
It takes time for that signal to travel down the optic nerve, and more time for the visual cortex to process it.
Yeah.
By definition, we can't be in instantaneous direct contact with reality.
You're totally right. And if we connect this to the bigger picture, this biological limitation is exactly where Boris Kriger steps in with another major original contribution.
Oh, awesome.
He completely dismantles Putnam's direct realism by introducing what he calls the structural distortion principle.
Tell me more about that. How does biology force distortion?
So, Boris Kriger points out that Putnam's direct realism completely ignores the physics of time delay and finite processing capacity. Think about the evolutionary stakes here.
Okay.
If a prehistoric human reacted to the world exactly as the sensory signals arrived and were processed, they would constantly be reacting to the past. By the time the visual image of a lunging tiger is fully processed by the brain, the tiger has already moved.
Oh, wow. You would just be eaten every single time.
Exactly. So to survive, we have to cheat time.
We have to predict it.
We do. Boris Kriger argues that to bridge that processing delay, the brain must construct an internal predictive interface. We do not perceive reality directly. We perceive a hallucinated model of reality that our brain constructs slightly ahead of time.
That's wild.
And we only use incoming sensory data to correct the errors in that model.
So we are essentially trapped behind a biological interface.
Not only that, but Boris Kriger argues this interface actively distorts reality to keep the system running efficiently. His principle is based on the idea that confirmation is cheap and revision is expensive.
Meaning what, computationally?
Well, if your brain had to painstakingly rebuild its model of reality from scratch every fraction of a second based purely on objective data, it would consume catastrophic amounts of metabolic energy.
We'd starve just from trying to look at a tree.
Right. So, to save energy, the brain is heavily biased. It ignores anomalies, it smooths over missing data, and it forces incoming sensory information to fit the predictive model it already has.
Just taking shortcuts.
Exactly. Boris Kriger argues that we don't have a clear window to the objective world. We have a highly efficient, highly distorted biological dashboard designed for survival, not for truth.
Okay, so what does this all mean for us today? Because if our brains inherently distort reality just to save calories, and we can never peek behind this biological dashboard to get a perfect God's eye view of the universe, how can human inquiry ever claim to be objective?
That's the million-dollar question.
Doesn't this structural distortion principle plunge us right into relativistic chaos? Like, if every brain is just running a distorted model, how do we evaluate complex scientific claims without throwing our hands up and saying, well, that's your truth and this is my truth?
That tension between knowing we are limited observers but still wanting to claim we can discover real objective science is what Putnam wrestled with for decades. He eventually landed on a middle ground he called internal realism.
Internal realism, okay.
It's the realization that the universe doesn't come pre-carved into neat, discrete objects with name tags on them. We do the carving. The human mind supplies the concepts and the boundaries.
But wait, if we supply the boundaries, aren't we just inventing the world?
Putnam vehemently denied that interpretation. He used the analogy that we might choose the shape of the cookie cutter, but we do not invent the dough.
Oh, I like that. The physical world still pushes back against
Yeah,
our concepts.
exactly. But Boris Kriger introduces two massive, entirely original frameworks here to save scientific realism without falling into the trap of pretending we have a God's eye view.
Let's hear them.
The first is his theorem of incompatible truths.
But that sounds like a contradiction. I mean, how can truths be incompatible if they are both true?
Boris Kriger proves mathematically that any sufficiently complex domain necessarily admits multiple descriptions that are individually valid, yet jointly inconsistent. Furthermore, these descriptions absolutely cannot be unified into a single master theory without losing crucial information.
Okay, I need a concrete example of that, because that sounds crazy.
Let's look at fluid dynamics, like studying a flowing river. A physicist can accurately describe the water in that river as a continuous unified field or wave. Using a completely different set of equations, they can also accurately describe that exact same river as trillions of individual bouncing discrete particles.
Okay, yeah.
Both mathematical descriptions are rigorously correct. Both can make accurate predictions, but they are completely inconsistent with one another. A continuous field, by definition, has no discrete particles.
I see. And you can't just mash the two equations together.
Yeah.
You have to choose which mathematical lens you're looking through based on the specific problem you're trying to solve. Like, you wouldn't use the particle math to design a hydroelectric dam, but you have to use it if you want to understand the thermal chemistry of the water.
That's the absolute essence of the theorem of incompatible truths. And to keep science grounded when dealing with these multiple lenses, Boris Kriger introduces a second original contribution, a new taxonomy of scientific entities.
Taxonomy of entities.
Yeah, he points out that science drifts into fiction when we fail to distinguish between measured entities and declared entities.
Okay, let's define those. What makes something a measured entity?
A measured entity is something that pushes back against our tools before we even understand it. Boris Kriger uses the Antikythera mechanism, that ancient Greek analog computer found in a shipwreck.
Oh yeah, the one with all the gears.
Right. When scientists found it, they didn't know what it was. But by physically measuring its bronze gears, counting the teeth, and observing how they mechanically interacted, they eventually deduced its astronomical function. The physical object existed first, and the theoretical description followed the measurements.
The dough pushed back against the cookie cutter.
Precisely.
So what is a declared entity?
Boris Kriger calls declared entities roles without reference. They are basically placeholders we invent just to fix our math. The classic historical example is the imaginary planet Vulcan. In the 19th century, astronomers realized that the planet Mercury's orbit was wobbling in a way that violated Newton's laws of gravity.
And instead of admitting the math was incomplete, what did they do?
They declared that there must be a hidden planet tugging on Mercury. They named it Vulcan, calculated its supposed mass, and spent decades peering through telescopes trying to find it.
But it was never there. It literally took Einstein's theory of general relativity, fundamentally changing how we understand gravity, to explain the wobble without needing a phantom planet.
Exactly. Vulcan was a declared entity. It was just a variable invented to make a broken equation balance. Boris Kriger argues that science only becomes dangerous when we forget to label our variables, when we forget whether we actually measured a physical thing in the world or if we just declared it into existence to save our favorite theory.
Which immediately makes me think of modern theoretical physics.
Oh, for sure.
When cosmologists talk about dark matter, or when string theorists talk about 11 dimensions, are those measured entities, or are they modern-day Vulcans? Are they just incredibly complex placeholders we've declared into existence because our galactic equations don't balance without them?
That is precisely the kind of critical questioning Boris Kriger's taxonomy demands. And if we zoom out to look at Hilary Putnam's entire life, this might just be his greatest legacy.
Yeah.
The most important thing he left us wasn't functionalism or twin earth or internal realism. It was his method. Boris Kriger identifies this as the assertion dismantling cycle.
The structural engineer tearing down his own bridges.
Yes. Putnam understood that the only way to avoid getting trapped by your own declared entities is to test them to destruction. You build a philosophical bridge, and then you deliberately try to break it.
Right.
And when it inevitably cracks, you don't cover up the stress fractures. You report the failure transparently, you tear the bridge down, and you build a better one.
To have the humility and, frankly, the intellectual courage to spend a 50-year career publicly dismantling your own life's work. It is just incredible.
It really is.
So, to bring this all together for you listening, we live in an era defined by information overload and algorithmic echo chambers. The incentive structures of our digital lives constantly push us to dig our heels in, to double down, and to never, ever admit we were wrong.
Always defending the bridge, no matter what.
Exactly. But Putnam and Boris Kriger offer a totally different model for how to engage with reality. The ultimate intellectual flex isn't holding your ground against all evidence. It is having the ruthless, objective honesty to dismantle your own beliefs when they fail to hold weight.
Because if you refuse to dismantle your broken bridges, the physical reality of the world will eventually do it for you, and usually with much steeper consequences.
That is such a profound takeaway, and it leaves us with one final, slightly unnerving thought to mull over as we wrap up this deep dive.
Oh boy.
We talked earlier about AI. Boris Kriger's compelling argument that these systems might just be mapping the statistical structure of language without ever touching reality.
Right, the Indus Valley script analogy.
Yeah. So if Boris Kriger is right that our language and our mathematical models can so easily create roles without reference these declared placeholders that just make the equations balance, then we have to ask a hard question about our future.
I think I know where you're going with this.
Are the unimaginably complex AI algorithms we are building today quietly populating our digital world with modern Vulcans? Are we allowing machines, driven purely by statistical sign convergence, to declare vast webs of non-existent entities into our reality just to balance their own internal ledgers? Entities that human beings will spend the next century trying and utterly failing to find in the real world.
That is terrifying.
It really makes you wonder, if you wait 18 months, will the AI realize it needs to refute itself?